Ready. Wonderful. So thank you very much. This is called like grinding parentheses to form rubies. It's a talk about how I reuse like 85% of my code. I actually calculated this number. It's not like a random thing that I put here. So how do I reuse 85% of code between two different plugins? So just to like for completion is I'm Maurício Szabo. I'm the author of Chlorine for Atom and also another Atom, like a fork called Pulsar, that I keep with the community. So I'm kind of like co-author. And I've been working with Clojure, ClojureScript, Ruby, a little bit of JavaScript and Python for most of my life. And now I'm the author of this new plugin, Lazuli, which I'm not going to show in all its entirety, but it's the subject of this talk. So that's like part of it. Okay, so what is Chlorine? If you're not familiar with it, it started as a socket REPL plugin for Clojure for the Atom editor. And the reason that I started with this idea that I wanted a socket REPL and I wanted to be written in ClojureScript because at the time I was using some other plugin that was pure JavaScript, and converting between Clojure data structures to JavaScript was kind of like a sad reality, and I wanted something better. And at the time Atom was dying. This information is important because I wanted the plugin to be written in such a way that I could remove all the Atom stuff and then migrate to another JavaScript-enabled editor at a time. And this whole thing is an extreme example of the strangler fig pattern. If you're not familiar with this pattern, it's basically, suppose you have a very old code or, I don't know, legacy thing that you want to phase out of your code base. So how could you do that? It's like doing a big rewrite. It's not feasible in most of the cases. So this pattern is you like pick your code that you want to remove, and then you surround it with new code. For example, suppose you have a database, a legacy database, and you want to migrate to a new database, and then you start to like do a query in the new table and then somehow integrate with the old code, and do that over and over and over until you have all your old code surrounded so you can strangle it away of your code base, and that is basically the strangler fig. So this whole plugin started thinking about how could I strangle everything that was Atom if that was needed. So to do that, I decided to make all the plugin, every logic and everything in this library that I call REPL tooling, which is actually kind of bad name. I didn't like it that much and I don't like it right now. And make all the implementation details for Atom inside this other plugin called Chlorine, which is just a client for this library. And then Clover, which is the VS Code version, is just a client for this library. And it doesn't add anything or patch anything about this. So now I decided to like remove socket REPL support for Chlorine, and I got like the opportunity to rename the library to Tango because I didn't like the name at all. But also because like in the spirit of Clojure, I wanted to keep Chlorine and the old version as it is, so somebody will have like, okay, this was a socket REPL implementation of a plugin. This works, and if they want to, I don't know, continue or at least study the implementation, it's there, it's archived. But I made this new library called Orbit, which is an NMREPL client for ClojureScript, and also a shadow CLJS API, but it's not important for now. It's a different kind of REPL for ClojureScript that I think is better for my needs. And then I did this duck REPL library, which is a kind of funny library that I want to show you a little bit later, and then Tango, and then Chlorine and Clover. So this is how things are now. This is the next version of Chlorine that I keep failing to like publish for a while right now. And the way that you use this library, it's like this. You have a code along that calls connect. You have a host and a port and a bunch of callbacks. The host and port are in REPL ports, host and ports. And the callbacks are actually how you integrate with the editor. So here I have some callbacks, for example, what happens when I disconnect the editor? What happens when I evaluate something? What happens when the editor needs something that's editor data, and so on. And this is for the Atom editor or the Pulsar editor right now. And this is for VS Code. As you can see, it's exactly the same code, nothing like changed except the callbacks. Like here is like UI send output, here it's something different. And here's an example of a callback for the Pulsar editor, which uses the Atom API. And here is like the VS Code version, which uses the VS Code API. But you can see that if I return this data structure, it doesn't matter what editor you're using. You can even not use an editor at all. I can like simulate that you have an editor and just like feed text to it and it will work fine. This is a different example of callback, and this like shows a little bit the actual difference on implementation on Pulsar and VS Code. Like here, what happens in this callback is like I sent an evaluation for the REPL and then I need a result. So I have this inline update. For those that are not familiar, the Atom and the Pulsar editor, you can have results that are below your actual source code. And this can be like arbitrary stuff like HTML and JavaScript and everything. The VS Code version does not support that. So for the VS Code version, I have this post message, which basically says, okay, this will have to be rendered somewhere else. In VS Code case, this means a web view. So VS Code have a web view and I can post something to this and I serialize the stuff and send to the web view and the web view decides how to render that. But it's essentially the same thing. Like evaluated something for the Pulsar, it does an inline thing, and for the VS Code, it posts a message to the web view. That works. Okay, so this is Tango. This is how you interface with Tango. And now I want to speak a little bit about this amazing library called Pathom and how I use that in a very bizarre way, actually. And okay, if people are not familiar with Pathom is kind of like a GraphQL library, but it's not GraphQL. Actually, it's CQL, which is similar to the pool syntax for the Datomic database, but Pathom allows me to decouple my inputs and outputs and then do queries. So what is DuckREPL? It's a library that registers some resolvers and some attributes for Pathom and allow me to make all the interactions with my REPL and my editor like queries. So here's how it works. First, what is Pathom? Like Pathom have this concept of resolver, which here is a square. It have the inputs that I accept, the outputs that I will provide, and a resolve function that basically will convert this input to some output. So for example, here I accept the user ID as an input and I will provide a user login as an output. So what I will get in the input, it's a map containing user ID. And what I will provide, it's a map containing this attribute user login. And I don't in Pathom say this resolver depends on that other resolver. I say I have an input on this resolver. And if this input is the same as another resolver's output, then Pathom will do the graph for me. So here I have a different resolver that depends on the first one. Here I have a resolver that depends on two different inputs. And if those inputs are returned from two different resolvers, Pathom will do the queries in the right order. And here's another example of a resolver depending on role ID. And the way it works is that I say what I have, which is the entity. So I have user ID and page URL, and I want authorization allowed. So Pathom is intelligent enough to say, okay, you want this, so I won't ever run this. So it will basically backtrack and say, okay, to do this, I need this. And to do this, I need this. And to do this, I need user ID. And I have user ID. So I will call the resolve function, get back the result, If the result contains the attribute, then it will call the second resolver, and so on until I got to the result that I am allowed to access that page. Now imagine this in the context of an editor. So here it is, duck REPL. For duck REPL, I decided on two attributes, basically, that are text, contents, and range. And they basically mean the contents of something and the range of that something. So suppose I have an editor. I ask for the editor contents, and what will give me back is whatever is in the active text editor, which is like the actual source code, and the range that is selection. So for example, 4748 is this B here. This is what it means to like have this range. It's zero based, so here is the line 0, 1, 2, 3, and 4. That's basically it. Okay, now if I can ask for other things that depend on text, contents, and range. For example, I can ask for the text selection, and this will give me back the B and the original range that this B originated. So for example, my original range was 4748, so it's just copied here, 4748, and the B, it's actually this B. Okay, so something more interesting right now. What is a text block? It's the inner block from the Clojure code, and now the range reflects the actual block, so from this parenthesis to this parenthesis. And the top block is the same. It will get the whole fn function, and the range will actually reflect that too. But the interesting part is that text contents can also be the input of a REPL result or a REPL error. So I can evaluate something if I have like text contents and text range. So supposing I get like the editor contents and I want the REPL result for the editor contents, it will evaluate the whole text editor. If I have like text block and I want the REPL result, it will try to evaluate -AB and so on. So a way to use that is to say that from the editor contents, I want the text top block and I want the range of that top block and the result. And the result will be basically whatever that top block evaluated. So here's a def1, so it will evaluate to a var. And the range will be the same as the range of the top block. Multiple things can return like text contents and range. For example, file contents can return like the contents of the file, and you can evaluate the contents of that file, or you can get the top block of that content of a specific file. And if the file is a jar file, it will try to unzip that and then get back the contents of whatever is inside that zip, that zip file inside the zip. So it's a very cool way, and it simplified a lot my work, because for those that are not familiar with how Clojure and ClojureScript works, you kind of have to dance a little bit between ClojureScript repos and Clojure repos and other stuff. Okay, so everything was fine, everything was cool, but then I landed up a Ruby job, and I was kind of lost because I would not be able to use any of this work that I found it very sad. So I decided to try to port Chlorine to Ruby, and this is the result. It's Lazuli. As you can see, it's essentially the same plugin, nothing that different. The console is actually a little bit different because here I have some shadow CLJS running. Here I have what is trace and watch points, which I'll show a little bit later. So for Ruby, what I decided, how I did that was simple, actually. I first got Chlorine and tried to connect to an REPL server on Ruby. Ruby didn't have a good or even working REPL server, so I wrote one. And then I selected something in Ruby that supposedly is the same as Clojure, for example, I don't know, a string, a number, and I asked for evaluate selection. And that worked at first try, if you ignore the 5 other times that it didn't. But yeah, basically like it worked, it was fine, but it wasn't fun. It wasn't like very useful either. Because, well, I have other stuff in Chlorine that I wanted. So what I did was I decided to remove everything that was not related to Ruby, and even things like block, top block, and then, and that's another part of that I find very, very interesting about like Pathom is that resolvers, they are not global. You have to put every resolver, every input, output, and resolve function inside a vector or some other collection, and then generate a query with that group of resolvers. So by doing that, by basically like putting everything, every resolver in a vector, I could also remove vectors that and resolvers that have nothing to do with like Ruby and start to re-implement them. So here is a Ruby code. If you're not familiar with Ruby, don't worry. It's not very important. It's just defining a class inside a module and some two methods, and that's it. Again, the same text range and text contents like work here because the REPL doesn't change the way that you read contents from the editor in Ruby. But I had to re-implement and rethink about what a top block means. So the naive way to think about what a top block is to get the whole class. But that's not what top block means in Clojure. In Clojure, we kind of want just a function. And I kind of wanted the same experience. So what I did was I changed the top block in Ruby to include the module in the class and then paste the method here and put a lot of ends here to basically close the full and bar classes. And that got me the same result because if you're not familiar with Ruby again, if you have a class definition with some method and you reopen the class with module class and def, you are patching that definition. So now full bar and def2 have a different implementation than what was originally in the interpreter. And it's dynamic, like even if there are things that are instantiated with that class, for example, I have some object running around, when it calls the method 2, it will use the new implementation. So I don't have to like clean up every old object and instantiate the now again. And the range will now reflect this. It basically says, okay, the def starts at line 6, but here it's starting at line 4 because it have to account for these two new elements. And the text block was easier actually because I decided that it was going to behave like an evaluate line, but not only line. It had to understand my code because like limit b, it's not valid Ruby code. So I decided that I was going to backtrack until I got into a full like pipeline and method chain, which is what this means, like user where limit. User seems like it's poorly indented, but it's not because it's saying that it started at column 6. So it's basically like starting at column 6, I have user and everything is like weirdly indented because it's like indented correctly. And again, that works, and that was it. So I just replaced the resolvers and Lazuli was done, right? And I wish things were that simple, obviously. Because, I mean, yeah, I got into lots of interesting ideas on this, but remember, Clojure is a flat language. You don't have classes, you don't have objects, you don't have to instantiate things, and you don't have to like mutate stuff to get your class and your object into a valid state so you can start to run methods. Ruby is basically the complete opposite of that. So for example, here's a user controller. It's something that is instantiated by the Rails framework, so I don't even know how to instantiate this class. I could like define some global variables here, but that was going to be no fun like really fast because, I mean, I have these class variables, but I also have self, I also have parameters, and I also have these weird like DSL-like elements and patches and other stuff. So defining global variables for everything was not going to be fun. But luckily, Ruby has something that I call trace point. And trace point is a way to hook into the interpreter and start to like get stuff like, for example, when a method is called, then call some callback. So what I did was I generated these things here that I call watch points, and they meant like if you are interacting with your application, save the binding of this method somewhere in the REPL state, and when you evaluate some line, then like use that binding and the local variables and basically the self binding and everything to evaluate something that makes sense. So here I have like @user, which is the same thing as self.user, and it resolves correctly because I have the binding available in runtime at any moment. And also another thing that I wanted is I wanted my code to understand Ruby, meaning that I don't want to render strings here. I want to render actual Ruby data structures. It's harder than it seems because Ruby is not homoiconic like Clojure. So I have to parse the Ruby result and see if it makes sense. Sometimes it does, sometimes it doesn't. So it's still a work in progress, but for most of the cases, it works really, really well. And for that, I had to hook into the Tango library. So the REPL was done, the things that I could do. It understands my code, it understands the block and top block and everything, but I had to go to Tango again. And here's another idea that I decided since the beginning, and it paid off really well for me, is that commands, actions, and features and other stuff that the language supports are not global. I got a little bit lucky on this because VS Code is actually have a really weird API sometimes. So I kind of had to like dance Tango, pun not intended, but welcome anyway. So yeah, I have to like do some kind of work and dance to get everything together and not have anything globally defined so that the web view could access or could patch stuff when it needed. So when you connect to a REPL in Tango, you get back this thing here that I call state, or it might be like connection state, editor state, whatever. And it contains things like editor commands. So things that are here are, for example, evaluate top block. So if I patch this, that means if I connect to a REPL and swap editor commands evaluate top block to something that understands watch points, then watch points will start to be understood by all plugins that use Tango, which is what I did actually. So I patched like evaluate top block, I patched like evaluate block. I had to change go to var definition because it's completely different in Ruby. And here is another part that I find it very, very interesting. Autocomplete is also an editor feature, so I changed that to autocomplete Ruby and not Clojure. And this poorly named function here, result for render, what it meant is, given a Clojure data structure, I will get back a hiccup data structure that represents something that I'm going to render in the editor. So why a hiccup and not an HTML stuff? Well, because I wanted my plugin to work in like other environments that might not be the browser. So for example, if I want to support NelVim in the future that runs like Node.js plugins, supposedly I can. I just need to define some of the hiccup that I use in terms of like text structures and lines and columns instead of like HTML functions. It wasn't that easy in the first version of Chlorine. It's easier on this one because the actual version of Chlorine that I'm working for some time, it's not using like div and span. It's using things like symbols. So for example, UI/rows for rows, UI/cols for columns. So it's easier to do that right now. And that's the route that I wanted to do. This had to change too for Ruby because again, I'm not parsing Clojure anymore. I'm parsing Ruby. So now I receive a Ruby stuff and I want that to become like something that renders correctly in the screen. Okay, so how is Lazuli structured right now? notice that I don't have chlorine anymore here. There's a reason for that. So at the beginning, I decided to get everything that I wanted and put inside the Pulsar and the Lazuli plugin. But then somebody said, okay, can you do a VS Code version? And I was like, okay, I can do a VS Code version. So instead of like copy pasting everything from the Pulsar to the VS Code, I decided to do this shared library-ish. It's a submodule, it's not published anywhere, but it's a submodule. You can like include that in your editor if you want to do some work on this. And both Pulsar and VS Code versions of Lazuli depend on this Sapphire. And the Sapphire is basically consume Stango and do the changes that I need to do. It's a small-ish library. I think it's, I don't know, 1,000 lines of code most. And a good part of that is like parsing Ruby structures into something that makes sense. So it's not heavy to parse and to understand. So this is how Lazuli is structured right now. And here is how now I have two Lazulis, one for the VS Code editor and one for the VS Code version and for the Pulsar editor. As you can see, it's like the same plugin. There are some CSS stuff here. For example, this is red, this is not. So, but again, everything that I have in Chlorine and everything that I have in Lazuli are here. They are essentially the same stuff. If you want to see more, I do have a REPL open here, so I can like show you. And I want to open for questions right now. I do have some more stuff for the future, but I prefer to use this time for questions. And if we have time, I can speak a little bit more about the future of this plugin. I know that I spoke a lot about new stuff, so